can you solve this math challenge? Here's the question. If 2x raised to the 5th power equals 5y raised to the 7th power, then what is the smallest possible value of x plus y? Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. But before that, I will show you my answer to this question. And my answer is the smallest possible value of x plus y turns out to be negative infinity. Alright, this is my solution to this question. So the given is 2x raised to the 5th power equals 5y raised to the 7th power. And our goal is to find the minimum value of x plus y. Now, it turns out that by observation, x can be 0 and y can be also equal to 0, and they are equal, of course. So the minimum is just 0 plus 0 or simply 0, but no, 0 is not the minimum value of x plus y, because as I said earlier, it turns out to be up to negative infinity, and I will prove to you that it turns out to be negative infinity. So let's start our solution. First, let's replace this x, and the value of x must be equal to 2 raised to a times 5 raised to the power of b. And we replace also the variable y, and let y be equal to 2 raised to c multiplied by 5 raised to the power of d. So why we do that? Because of this numerical coefficient, we have 2 and a 5. And we want to make this left-hand side and right-hand side equal. So we choose x must be 2 raised to a times 5 raised to b, and y 2 raised to c times 5 raised to the power of d. So let's replace all x and all y. Like this. Now let's use some laws of exponent. Take note that when we have k raised to the power of n raised to the power of m, this can be written as k raised to the power of n times m. Therefore, we can distribute or we can multiply n and m. Therefore, the left-hand side can be written as 2 multiplied by 2 raised to 5a multiplied by 5 raised to the power of 5b, like this. And on the right-hand side, this can be written as 5 multiplied by 2 raised to 7c multiplied by 5 raised to 7d, like this. And again, let's recall some laws of exponent. If we have the same base, k raised to n times k raised to the power of m, this can be written as k raised to the power of n plus m. So we can add their exponent if we have the same base. Now, on the left-hand side, take note that we have 2 here, and this exponent must be equal to 1. And we also have the base 2 right here, which is the exponent of 5 times a. So the left-hand side can be written as 2 raised to 5a plus 1 multiplied by 5 raised to the power of 5b. Also, on the right-hand side, we have here 5 with exponent of 1, and we have also the base 5 with exponent of 7d. So this can be written as 2 raised to 7c multiplied by 5 raised to 7d plus 1. Alright, so let's focus on this product. Since they are equal, therefore, their exponent must be equal. It follows that by comparison, we can say that 5a plus 1 must be equal to the exponent of 2 on the right-hand side, which is 7c. So, we can say that 5a plus 1 equals 7c. Now, this is an example of a Diophantine equation. In short, there's a lot of possible values for a and c. For example, a can be equal to 4 and c equal to 3. The reason is 7 times 3 must be equal to 21. And 5 times 4, this is 20. And 20 plus 1 is the same thing as 21. So a can be 4, then c equals to 3. Now, another possible. So again, there's a lot of possible values of a and c here. So this can be also a must be 18 and c equals to 13. or A can be 32 and C equals to 23. You can check the values of A and see that they are the same or they are equal. The left hand side and the right hand side are equal, and so on and so forth. In short, there's a lot of possible values for A and C. Now, how about the second term? 5b, the exponent of 5 must be equal to the exponent of 5 on the right hand side, which is equal to 7d plus 1. So we can also check those possibilities. Again, this is a Diophantine equation, so there's a lot of possible values for b and d. One possible example is when b is 3, d is equal to 2. The reason is 5 times 3. 5 times 3 will give us 15. And 7 times d is 2. So 7 times 2 is 14. 14 plus 1 is the same thing as 15. So they are equal. This is the same also when b is 10 and d must be equal to 7, and so on and so forth. Now, take note that this equation holds true using the first value of a, b, c, and d. This value is 4, 3, 3, and 2. Now, let's check this value if this is true. So, A must be equal to 4, C equals to 3, and then B equals to 3, and this D equals to 2. So, the left-hand side must be equal to 2. 2 raised to 5 times 4 plus 1, or simply 2 raised to 21, multiplied by 5 times 3 is 15, so this is just 5 raised to the power of 15. Now, the right-hand side must be equal to 2 raised to 7c, or 7 times 3 is 21, so we have 2 raised to 21, multiplied by 5 raised to 7 times 2 is 14, plus 1 is 15, so 5 multiplied by 5 raised to the power of 15. Take note that they are the same thing. Now, this first value of A, B, C, and D works. Therefore, the second possible values of A, B, C, and D also works. This set of values, 32, 23, 17, 12, also works, and so on and so forth until we reach the largest possible values of A, B, C, and D. Now, saying this, let's go back to our original equation. 2x raised to the 5th power equals 5y raised to the 7th power. Now, notice the exponent of x and y. We have 5 and 7, and they are both odd number. Therefore, a negative number raised to an odd power, it turns out to be also a negative number. Therefore, if we choose x and y to be a negative number, because we want the minimum possible values of x plus y, so we choose negative value for x and negative value for y. And it turns out that the left-hand side and the right-hand side be equal to a negative number. They are still the same. And also take note that we can choose the largest possible values of a, b, c, and d. Therefore, if we find the sum of x and y, this can be written as x plus y equals to negative 2 raised to a times 5 raised to b minus 2 raised to c times 5 raised to the power of d. Now, we can factor out negative 1. So, the right-hand side can be written as 2 raised to a times 5 raised to b plus 2 raised to c times 5 raised to the power of d. And a, b, c, and d can be as large as possible, as I said earlier. So this number right here becomes very, very huge number, and it turns out that this number right here can be equal to the largest possible value, which is an infinity. So x plus y, the minimum value of x plus y, turns out to be approaches to negative infinity. And that is the answer to this question. And as always, we are done.